Hello and welcome to Debug School. This time we're talking about a technique that I lovingly call the bug sandwich. Have you ever meticulously followed a code tutorial step by step, but only to get an error when you actually try to run the code? Have you ever found a broken feature in your app that you know for sure it used to work before? Have you ever tried to do something you've done many times before, but for some mysterious reason, it is simply refusing to work this time? Have you ever been in a situation where your app works for you perfectly in development, only to break when it is deployed to production? What do all of these situations have in common? Well, in each of these cases, you can identify a version of the code, or test case, that is working and an alternate version that is not working. What can you do about this? Well, you can certainly throw your hands up and give up, be like, oh, the gods are mocking me, or you can take advantage of this situation. Clearly, there is something different about the two test cases. What is it? If you can find the key difference that makes one of them work and the other one break, then you can figure out the root cause of the problem. The technique that I'm going to show you in this lesson is called the bug sandwich, and that is precisely what it does. Imagine that you are a bug, and you have fallen into a trap. You've been dropped into the middle of a room with no exits. The two walls on opposite sides of the room have spikes coming out of them, and both of them are moving and they're coming right towards you, slowly. You are sandwiched right in the middle between these two walls, and you have no way to escape. You are trapped. Your demise is imminent. All you can do is to say your prayers while you await the inevitable. For the bug in pursuit, this is what it feels like when you deploy the bug sandwich upon it. From your perspective, it can sometimes feel a little sadistic. This is how it works. To use the bug sandwich, you need a test and two test cases, a passing case and a failing case. Initially, the passing case should pass the test, and the failing case should fail the test. The test doesn't necessarily have to be an automated test. You can certainly do the test manually. The most important thing about the test is that its results are consistently reproducible. Your objective is to find the smallest difference between the two test cases, such that removing that one difference either causes the passing case to fail or the failing case to pass. The actual procedure goes like this. First, you identify the differences between the two test cases. Then, you go through each difference one by one. For each difference, remove that difference by either modifying the passing case to match the failing case, or by modifying the failing case to match the passing case. Then you run the test again on the test case that you just modified. If the test case result flips, i.e. the passing case now fails or the failing case now passes, then you have found the failure-inducing difference. Now, let me demonstrate. I'm making a to-do list application using the Koa web application framework. Currently, the app only displays a list of tasks to be done, but I have yet to implement a feature of allowing the creation of a new task. As you can see, both of the existing tasks have been hard-coded into my app. Right now, if I try to create a task by typing it into this text box and then hitting enter, it makes a post request to the task's URL, but I don't have a handler set up for that yet. So it comes back with an error not found. So I'm going to make a handler for it. If implemented correctly, this form post handler should receive the input values and get the values posted from the form via the object this.request.body. And it should receive a parameter called new task name, because that's what I chose to call the input element in this form. So I'm going to print out this.request.body.new task name to see that the value has been correctly passed in. To test this, I will come back to the task list, type hello, and hit enter. I'm getting internal server error. Looking at the terminal, I can see that I have an error on line 35. Type error, cannot read property new task name of undefined. So evidently, this .request.body is undefined at the moment. And that reminds me that with the Koa framework, in order to receive post parameters, I actually have to install a body parser library as a middleware. So I'm going to go ahead and look that up on Google really quick. There are actually several body parsers for Koa. I'm just going to select the first result. Okay, I like this README page because the first thing that I see is a simple example of how to use it, which is exactly what I need. I'm going to use this as a reference and type the relevant bits into my own app. First, I need to require the module Koa body parser. Then I need to tell the app to use the middleware. Okay, there we are. Now let me try that again. Type in hello again, hit enter, and I get the same error. Now I'm a little confused because I have used this module before in another app and it has worked for me before. So why isn't it working for me right now? As you might have guessed, this is the point where I'm going to employ the debug sandwich. I'm going to bring up the other app that I made and I'm going to use that as the passing case. This app is called Hello and it simply asks your name and that it will greet you by saying your name back to you. The key thing that we care about and want to test is that it actually successfully takes input from the form and renders it back. So I'm going to type in my name, submit the form, and it does say my name back to me. So it does appear to work. To start the procedure, I'm going to put these two source files side by side so that I can easily spot any differences between them. The first difference I see is the use of uStrict on the left side. This probably has nothing to do with the cause of the problem, but nonetheless, I'm going to remove it by adding this line to the right. Now, since I changed the right side, which is the Hello app, I'm going to retest it, and it still passes. The next difference that I see is this extra set of parentheses over here on the right. I'm going to remove them to make both sides the same. But there's probably a good reason these set of parentheses are where they are. So I'm going to search in both files for the place that the body parser variable is used. Here I see that on the left side, we have the parens down here where the body parser is registered as a middleware, but not on the right side. So I'm going to match those as well. And again, this really should make no difference to the outcome, but just in case, I'm going to test it out, and the Hello app still works. The next difference I'm going to remove is a big one. I'm going to change the entire functional behavior of the app on the left side to match that of the right side. I'm making this drastic change because right now, the thing I care most about is whether or not the form pose is working and not the behavior of the app itself. So I'm going to copy the code that implements the Hello app into the left to replace the code for the To-Do app. Now let me retest the app on the left side, which used to be the To-Do app, but now has become the Hello app. I'm going to type Toby and hit enter here, and I get an internal server error, which is interesting because we now have a non-working Hello app on the left and a working Hello app on the right. So we're making progress. So right now, the left side and the right side are identical all the way up to line 25. The remaining differences are, number one, the ordering of the two lines here, and the port numbers. I really don't think the port number is likely to be the deciding factor. So I'm going to flip these two lines here and retest. And it now works. So the flip has occurred. Namely, the failing case on the right is now working. So we now know that the failure-inducing difference is the difference in the order of these two lines. And this tells us that the order is important when it comes to registering middleware with the Koa web framework. What I will do now, knowing what I know, is to revert the left side back to the to-do app that I had originally, and then reapply this fix so that I can have an actual working to-do app. So let me test this. And I get a not found. Looking at the terminal, however, I see that I did get the name of the task printed out in the terminal, which means the forum post did actually work. We just have to write the code to handle it. So the thing left to do is to add a new task to the tasks array and redirect the page back to the tasks page. Now let me test this again. And now I'm able to add new tasks to the list, just the way that I planned. So that is the bug sandwich at work. Now I want to talk about the various situations where you can apply it. The first situation is if you are so lucky to have another existing app, as I did in the demo, that is relevant to what you're doing and can serve as the passing case. Scenario 2 is when you're following along a code tutorial and you encounter an unexpected error or behavior when you try to run the program. Most of the time, you have access to downloadable or copy and pasteable demo code, which should work right out of the box. And providing that demo code works, and you will definitely want to test this first to make sure that is the case, you can use that as the passing case. Scenario 3 is when you find a broken feature in an application and you know for sure that that feature used to work before. If the project is under source control, you can likely find a previous version of the app where the bug is not existent. So if that's the case, you can use that previous version as the passing case. In fact, the version control system Git has a feature called bisect, which is used precisely for doing this. In a separate lesson, I'm going to cover using source control for debugging in a little bit more detail. Scenario 4 is when the app is working for you in development, but is broken in production or another environment. There, the challenge is not in finding the difference between two source files, but rather finding the difference between different environments. As usual, I'm going to leave you with 2 exercises to work on in order to help you to remember this technique in a deeper and more memorable way, so that when you actually need it in the heat of battle, you can summon it up. Until next time.